What I'd like to do is first paint the picture at a very high level of where we are in the transition from the ICE and the BEV, and then I won't be able to resist a little advertising of our new electric vehicle center and the opportunity to join with us. So if you're going to talk about the changes going forward, it's always good to take a look at history, right? Forget history, you'll repeat the mistakes of the past. If you look at the first era of automobiles, and I'm talking the late 1800s to early 1900s, there were startups. It was the entrepreneurial center of industry, and there was a battle between wood, steel, and aluminum for the body, and there actually were electric vehicles. This one was in Paris in 1881. Then the English introduced one, and there was a French one, but by the early 1900s, I'd say the center of automotive innovation for the mass affordable vehicle moved to Southeast Michigan. And you had the various players, the breakthrough being Henry Ford's affordable Model T, which in Henry's way was you can buy it in any color you want as long as it's black. The realization by General Motors and some others that people actually thought their car was a piece of art. They concerned about the design, and that's true still today, and so GM surpassed Ford, and that battle has been going between the Europeans and the US and now the global manufacturers. But basically, we entered an era where all people were concerned about was how beautiful the car was and how fast it went. That went through to about the 1950s. Most historians will declare that the golden age of automotive. I actually think it must have been a boring time for the engineers. The product development time for a new vehicle was 1 year, because all they were basically doing was making it prettier and putting in a higher horsepower engine. There was no such thing about sustainability. No one even talked about that in any context in that time frame, but that changed in the last half of the 20th century. The first sustainability crisis was, and as you know, I'm not always a fan of people who just make trouble and activists, but Ralph Nader gave the industry a kick that it needed with the Unsafe at Any Speed book. The reality is we now had enough vehicles on the road traveling at high speed and killing a lot of people. There really was no attention to safety in the vehicle, and that began the whole era of making the vehicles designed so the passenger could survive. And then the second sustainability issue hit us. It was artificial at the time with the oil crisis. I mean, I remember, I had just gotten my driver's license. My task from my father, so I could use the car on the weekend, was you could only buy gas on every other day. You were either an even or odd, depending on your license plate, and my job was to stand for 2 hours in line filling up his car, right? That then grew to the realization of oil prices skyrocketing and the attention to fuel economy, and the industry responded. I would argue this was a grand time to be in the engineering part of automotive. We actually reduced, with the catalytic converter, the emissions of vehicles by 99%. More than doubled fuel economy, improved crash performance, and in fact, relative to emissions, by the end of this era, by the year 2000, if you drove a car in California, in Los Angeles in particular, the NOx and SOx coming out of the tailpipe was less than the air that entered. There was one problem. We were also emitting CO2. And with the realization of the climate crisis associated with carbon dioxide, there was now a totally different sustainability issue for the industry to take on. And as long as you're burning fossil fuel, you are going to emit CO2. And if you're doing it on the vehicle, as hard as we've all tried, the idea of capturing CO2 on the vehicle seems to be out of our capability to engineer. So we have a fundamental issue of putting petroleum-based fuel in the fuel tank to power the engine is a CO2 emitter. You couple that with the growing vehicle car park. We are at the point where 1 in 7 people on the planet can own and operate a vehicle. That's over 1 billion vehicles. So whether it's safety, parking, congestion, or fuel, and you have to forgive me, I'm always going to show GM vehicles, I mean, it's still my company. The world can afford over 1 billion vehicles. Can we manufacture them, operate them, and dispose of them sustainably? Some of the issues seem to be well in hand. The CO2 problem is not. And so the roadmap for that transition was written in the late 90s. And the industry's been marching to it. As we talked about, you can dramatically and incrementally improve the performance of internal combustion engines. On that one, I remember when I joined GM, I was a body engineering guy, and saw the roadmap for the improvement of the fuel efficiency of the internal combustion engine. It was actually, came out of University of Wisconsin, is how far, in the 1980s, how far could you improve the efficiency of today's architecture of internal combustion vehicles? That was mapped, and by 2005, we hit it. With homogeneous charge, compression, ignition, you've got gasoline engines operating close to diesel efficiency. Any other major change really requires a change in the architecture of the engine. And so, fortunately, the whole idea of doing 2 hybrids surfaced. It turned out you could make them with small enough incremental cost that it was value to the customer over the operating range, and became the focus of the industry. Then it moved to plug-in hybrid. One of the vehicles I'm most proud of being part of was the Chevy Volt. By the way, anybody know why we picked 40 miles range? The average commute distance was 40 miles, and that's what we told the public. The reality is, Bob Lutz kept telling us to do it, and that was the best battery pack we could fit on the vehicle, but it happened to match. And there's been improvements of that, and there are some companies today saying that's the right transition strategy. I actually believe in that. The question is, how fast are we going to get the pure electrics ready? There are 2 options there. One is the battery electric vehicle, which we'll be talking about today. The other one is the hydrogen fuel cell. And GM and others, we invested billions of dollars to get the hydrogen fuel cell vehicle ready. What we had at the time was nickel metal hydride batteries. This is before lithium. And the early lithium batteries were questionable. And so there was a race between the 2. From my perspective, for light vehicle, that race is over. Battery electric vehicle could win. I now have to add a caveat. The Department of Energy has set this goal for $1 per kilogram of hydrogen. I have my doubts that's achievable. If it does, the game changes. But barring that, we are on track to make the cost of ownership of a battery electric vehicle equivalent to or less than that of an ICE vehicle by end of decade. There are some remaining challenges, but fundamental premise I believe in. And so what does it take to do that? Because it's not just a vehicle problem. If I don't clean up the grid from CO2, I've made it more efficient, and I'll show you some data, but I'm still producing too much CO2 with today's grid on the BEV. A lot of the topics today, I need a robust grid that'll get the electrons to the chargers, an available charging infrastructure, which is what I hope to learn a lot about in the rest of the talks today, and then again, the vehicle cost of ownership. So let's go through those. Here's data, latest data. Transportation is a quarter of our CO2 emissions, and half of that is light-duty vehicles. It is a non-trivial contributor to CO2. BEVs win in that regard on today's grid. It depends where you're charging from, and this, we have data on that from various states, but in general, it's about half of the CO2 emissions in any class of vehicle as you move from internal combustion engine to hybrid to the BEV. One issue with that, and that's why we need to clean up the grid, but also once the grid gets clean, the CO2 emissions and of course the cost of producing the electric vehicle propulsion system is much higher than the internal combustion engine. And notice, most of that is from batteries. And a lot of that is getting the raw materials out of the ground. And so lots of effort to get that better. But now let's talk about focus today. My first job at General Electric was working on distribution transformers. We had this new soft magnetic material, and the goal was to replace the 25 kilovolt kVA transformers that are on the poles and outside your homes. And by the way, we succeeded, it's in place. But the key is, and I'm a little dated on this in terms of knowledge, anybody feel free to correct me. The grid is designed for, I believe it's 2 p.m. on August 7th. That is the peak use due to air conditioning and other things. And for a battery electric vehicle outside of that time, for the electron producers, electric vehicles are a gift. They have all that idled capacity that can be used. Our challenge is, what are you going to do when the total capacity in August is consumed by other than vehicles? Another issue, and I have reconfirmed this, during those times, the transformer outside your house at night is supposed to cool down. There's no active cooling in it, and if we start using those transformers to charge the vehicles at night while you're still running your air conditioners, there's an issue. So there is a capital investment required to get the grid ready for this, because, there's the story everybody tells. California passed the law. No more internal combustion engine vehicles sold after 2035. Anybody know what happened 4 days later? The governor of California, because they were having blackouts and brownouts, said, please do not plug in your vehicles. By the way, this is fact. The grid is not ready for this transition during peak loading. It's solvable, but it's high capital investment. Now we'll get closer to charging, which is the focus today. And there's a question of, where do you put the chargers? When I was doing my vehicle program at Ford, I was given one key word of advice. Go introduce your new features. It was going to be electric. We were going to do the integrated starter motor. It was, and some other features, and some wise and experienced vehicle chief said, never compromise on something that your customers are either used to or like, and try to make them convert and compromise on that for a new feature. That's generally true, right? And by the way, you have to take away the first adopters, are really strong. Oh, I'm going to go do the right thing for the environment. I'm going to go have fun with a BEV. I happen to be one of them. But if you want mass penetration of your product, don't take away and don't ask people to retrain their expectations. Today, almost anywhere in the world, you are 5 kilometers away from a 5-minute full recharge of your vehicle range. And while electric vehicle charging is more flexible, I haven't been to a gas station in 2 years. I come home at night, I plug my vehicle in, and the next morning it's ready. But the question is, where do you put the chargers? Well, you should put the chargers where the vehicles are. And by the way, there's a technical reason for that. We still have the challenge having batteries last life of vehicle with multiple ultra-fast charging. Pulling lithium in and out of the electrodes in a fast, very fast manner with today's chemistries degrades the battery. And so we must have $75 per kilowatt hour battery pack, has to last life of vehicle, has to last life of vehicle with numerous ultra-fast charge. We're getting there, but we're not there yet. And so, where's it put the chargers? Where the vehicles are standing for a long time. The majority of time, the vehicle is parked at home or near your home. During the week, it's at work. And whether you like it or not, or recognize it, it is one of the worst investments you make. You're driving it about 8% of the time. And over 90% of the time, it's sitting parked somewhere. So there's the whole question of shared mobility, driving that, but fundamentally, where do you put the chargers? Put them where the vehicles are. Well, that's great if you live in the suburbs. And I have to say, when I've got my Bolt, I have a relatively new home, 200 amp service. To put in my level 2 charger, they had to run a new line. I didn't have a 50 amp breaker, so there's money needed to get the infrastructure ready for home charging. But to me, the bigger question is, what are you going to do in the cities? We have to get a plug to a meter of every vehicle if you're going to do long-term charging. Ripping up cities is not the answer. I happen to think there is a holy grail coming, which is the self-driving car, which will take the car to a central charging station and bring it back. We've seen the problems of level 5 driving in the cities. Eventually this will be solved, but there is a fundamental issue. And over 50% of the world's populations will live in cities. How are we going to get a plug to a meter of every vehicle there? And maybe, that's a showstopper for a while, but it was pointed out there's the other 50% of the population that'll get us going. There's another part, which is we have trained everybody for about 100 years to expect 300-mile range on their car. Even when I was GM, I was challenging our library. How'd that happen? Have never found the article, and by the way, if someone has it, I'd love to see it. Why 300 miles? So I just do my own, and it's interesting. The Model T started at 200-mile range. Intriguing. Why did we go to 300 miles? Again, I don't know if this is true, just sort of logical. You take the average car, it has about 400 miles for a gasoline. The average person fills it up at a quarter empty. We're not all fume sniffers. So you get 300 miles per fill-up. Vehicle runs 13,000 miles a year. You're filling up your car once a week. Seems reasonable. On long trips, you can go about 4 hours before you have to fill up again. For a lot of people, that's a bio break, right? But we've trained people. Go fill up your car for 5 minutes. If you got to do a bio break, you got another few minutes because the stations have them, and you're on your way. The first adopters are willing to, I'm plotting my course. I'll get to a charger at just the right time. I'll spend, and they don't want to just top off because they got another 300 miles to go. Are they going to be willing to stay there for half an hour? Question we need to address. And I have to be honest, I just traded in my Bolt, which I loved, for the Cadillac Lyric. not because I wanted a Cadillac. I'm a professor now. I actually feel a little embarrassed parking the Cadillac in the lot. My Bolt, nothing wrong with it, in very cold weather was down to 150-mile range. I couldn't go back and forth to Toledo on a company I'm on the board of, right? With the Lyric, I'm back to 300 miles. We'll have to see what happens on longer trips, but that 300 miles feels comfortable. And so we have to keep that in mind. The challenge for this is how do we get not partial charge, which the first adopters will deal with. You want mass market penetration, don't ask people to change something they like. We need full recharge in 5 minutes. Maybe it becomes 7, but 30 minutes is not going to work for mass market. And then there's the whole question of getting the cost down. Again, I'm a believer that our roadmaps get us there by 2030. So let me just close by talking a bit about our new electric vehicle center. I'm in a little bit of marketing mode with this, forgive me, but it's a real opportunity. U of M has had a battery pilot line where companies come in, and I'll talk about it a little bit in a minute, where companies come in, 98% used by industry. How it ended up at U of M, I wasn't there at the time. It was a lucky coincidence that I took it over. They come in with their proprietary anode and cathode material, leave with finished cells that either we can test on our cyclers or they bring back. Happens to be an engineering service for companies located that. The only other alternative is at the national labs. We're easier to get into and lower cost. And so I went to the state. Our equipment was about 7 years old. It was time to upgrade it. Asked for a certain amount of money, and then the deans got involved. We ended up getting $130 million from the state of Michigan for a new electric vehicle center. Really a commitment by the state to do it. So again, a little bit on the battery lab. If any of you are interested, and again, occasionally we get researchers from academia. It's 98% used by companies. It's all IP protected. If you've never seen battery production, there's a little, other than the cost of raw materials, here's the difficulty. You come in with your powder. It's mixed into a slurry to get it to the right viscosity to coat. It's then coated and dried. After the dryer, and there's some making sure you've got full coverage, no pinholes, it goes into a slitter, which slits it into the size you need for your actually battery cell. You see it coming out of there, now it's going into the slitter, and basically goes through a series of steps where it's separated into the size you need, depending on your battery pack. You can see there the roll-up of those electrodes with the coated material. You weld on your tabs. It's put into a pouch. About to see the pouch is filled with electrolyte. The magic is in the chemistry, but the manufacturing steps are complex. And remember, one pinhole, one bent tab in one cell will take out a vehicle. And in the worst circumstances, the vehicle can actually have a runaway event. So this manufacturing process has to be 100% precise. We're just a pilot line to evaluate material, and you see the speed at which we're running. Commercial ones are running at 10, 50 times that speed. Think of the amount of square meter you're doing. And we can also do cylindrical cells, as you see there. So a little bit of advertisement, but I really wanted to give you a flavor of what it takes to make a battery. And so we are upgrading our facility as we speak. Our equipment is ordered. It's been an interesting experience being now, I'm 12 years in the academic world. It's very intriguing, having come from the real world. But part of what we signed up for and had money for was a building. When we started this, I remember the dean said, it'll take 5 years. I said, are you kidding me? I actually think it's going to take 7 years. Universities when it comes to facility, our research can move on a dime. When it comes to facilities, are a little slower. So I leased a building where we're putting the new battery line as interim. But most of the funds are actually going to workforce, education, and technology. Why did the state give us the money? They are concerned about jobs and factories. The reality is, it takes fewer people to make a battery propulsion system than a conventional ICE. And well, we've been the center, at least the Midwest has been the center of, in the US, automotive population, and Michigan being the hub for that. Battery plants, motor plants are opening around the world. And so how do we keep Michigan as the epicenter for the transition to BEV technology? And that means the technology home, the education home, and take care of the workforce transition. And so we lined up, just to get started, 12 companies spanning infrastructure to the OEMs and the supply base. Where are your gaps? Where are your needs? And this is what they've come back with. It looks like everything. In fact, there are priorities in here. Number one is they don't have enough engineers that are ready to do the electric vehicles. And that's the suppliers and the OEMs. And so we're actually starting, trying to quick start, a master's of battery engineering, a master's of power electronics and motors. And that, because we're a university, we can ramp up pretty quickly. The bigger issue the companies have is operators and technicians. How do you take someone who knows how to mill the face of an engine block and teach them how to assemble motors and batteries? Right? It's a very different workforce transformation, and we're going to be taking that on, working with the community colleges and others. And in fact, when my new battery pilot line comes online, we'll take our existing pilot line and have it for hands-on training of workers that'll go to the new battery plants. When it came to the technology side, I have to admit, I started assuming we were going to be on vehicle. We were going to deal with the motors, the power electronics, thermal management, everything associated with making the vehicle. By the time we talked to the companies, it became clear, well, wait a second. My bottleneck is often in the raw material and the supply chain. So we're going back there. And we have an issue of end of life. I mean, today the vehicle is one of the most recycled products on the planet. And particularly on batteries, the best we do now is treat them like they're material taken out of the ground and do some extractive metallurgy. That battery at automotive end of life is still at 80% capacity. And the idea that we're going to take that and just do extractive metallurgy just doesn't, it's the right interim solution, but we've got to learn how to repair, how to renovate, how to reuse. Okay, so I said, okay, I'm still on vehicle, but then talking to him, I said, no, you got to get off vehicle. This whole issue of the power generation, transmission, and charging has to be done. In fact, I personally believe it may be a rate limiter for the planned penetration. So the only thing I'm declaring out of scope, and this is just because we may have some money, but it was getting a little too large. I don't want to touch creating the electrons. But getting them to the charger, from the charger to the vehicle and a better vehicle, including end of life, is all now in scope. So we had with those 12 companies, and it was just a starting group of core companies, the initial priority areas defined. Not surprisingly, batteries, the most expensive and hardest to recycle component, is number one. The integrated drive module, and the others are quickly following. For those of you who think about that part, thermal management is one of the hardest problems the vehicle OEMs are facing. We knew how to handle high temperature heat coming out of the exhaust of an internal combustion engine. It's now low temperature, and the motors, the power electronics, and the batteries would prefer to optimize to operate at different temperatures. How do we handle that? So I pulled that out. A lot of pull on data, in-service data. The OEMs have it, the suppliers don't, the researchers don't, and you see right up on there the electric infrastructure and charging. So we're going to be starting workshops in each of these areas. If you want to participate, come see me. So I was at some panel a couple of months ago. It was in Detroit, and we were asked to make some closing remarks. And just off the cuff, I go, it's time to rebrand Detroit from the Motor City to the e-Motor City. I've never in my life had a standing ovation at a technical talk. And so I'm carrying it over to this, what's our vision? To make Michigan the e-motor capital of the world, right? If you want to join, you want to catch me, we're moving from soft launch to hard launch, starting projects, starting workshops. Please see me. And I actually left some time for questions. Thank you.